Hello friends, today I am going to discuss the non-ideality of real gases. So first of all, how to measure this thing? How to measure the non-ideality? So as we all know that for an ideal gas, we say that PV equal to nRT. PV equal to nRT. This formula is applicable only for ideal gas. And whatever formulas we have derived, we are seeing in thermodynamics, all are basically on this formula only, and is applicable to ideal gas only. In case of real gas, this P will not be same as nRT by V. For real gases, P is not equal to nRT by V. That depends on the way the real gases behave. So in to obtaining the non-ideality of a real gas, to get a pressure of real gas, we say one term known as a fugacity, which is denoted by phi. Fugacity. So what does this fugacity means, that I am going to explain in today's class. So this fugacity, we can say the birth of this fugacity is we can see from the free energy. The free energy, as we all know, that dg equal to free energy v dp minus s dt. At constant pressure, at constant temperature, this term will go off, and we can say that del G by del P at constant temperature is V. This V is of real gas, and this equation is applicable to ideal gas also. So for any gases, this application is relation is valid. So del G by del P at constant temperature gives me volume. So as we this to get the volume of a real gas, we have one equation well known as a virial equation of state. Virial equation of state we can write as PV by RT, where this V is for a real gas volume, and we can express this volume as 1 plus B1 P plus B2 P square plus B3 PQ dot 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 dot. Okay. So basically this extra term, this term, if I will omit this term, then this V equal to RT by P, that means this is a ideal gas pressure, ideal gas volume, and ideal gas volume is equal to real gas volume. That means when I will increase adding these terms, the gas will deviate from ideal gas behavior to real gas behavior. So why I am doing this thing? Because I want to estimate this P, real gas P, how this real gas P is related to ideal gas P. So if I will substitute this equation, PV by RT equal to this thing here, then I will get del G by del P is equal to del G by del T is PV, V I can write as RT by P into 1 plus B1 P plus B2 P square plus blah blah blah. Okay. So now if I will integrate this equation, from between the two pressure, that is real gas pressure and ideal pressure, that means if I will integrate this from P ideal to P, dg equal to RT ln of P by P ideal plus B1 P minus P ideal plus B2 P, what is P square? It was P square. Okay, so P square, that means it will become P, that is P square by 2 from P ideal to P real dot dot dot. Okay, So now this G I can write as G at temperature pressure minus G at T comma P ideal equal to these all terms. So now what I can do, I can simply write G at a given temperature pressure is equal to G at given temperature and ideal pressure plus these terms. So I want to estimate this thing. How I can estimate this thing? So this G at a given temperature and P ideal, I can estimate it from P naught, that means standard pressure, to the ideal pressure, because I know this delta G is equal to RT ln of P by P naught. This formula I know for ideal gas, it's applicable. It's I can write as G at a given temperature pressure is equal to G at given temperature and P naught, where P naught, see this P naught I can take as a 1, so plus RT ln of P by 1, that is G at a given temperature plus RT ln of P. Okay. Same thing for ideal case. If I will do, then I will get G at T comma P ideal equal to G naught at T, G naught at T plus RT ln of P ideal by P naught. If I will substitute this thing here in this formula, I can get it as G temperature and pressure is equal to G naught at a given temperature plus RT ln of P by P naught plus same thing, whatever extra term was there, plus B1 P minus P ideal plus B2 P square by 2 from P ideal to P plus dot dot dot. So from here I can say that these two terms, when the ideal gas moves from P naught to P, that is from low pressure at a P naught means standard pressure, that is 1 atmosphere, to at a given pressure, then for a ideal gas I can write this thing like this. But since I have taken non-ideality also in picture, then I have to add these terms also. So now what I am doing, I will simply take these terms out and I will say that RT ln of P by P naught plus B1 P minus P ideal plus dot 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 is equal to RT ln F by P naught, or F by F naught I can write, F by F naught. So this F by F naught, this term is known as a fugacity. So this term is known as a fugacity. Given pressure, that is pressure is replaced by fugacity, real gas pressure is a fugacity, and standard F naught. F naught tends to P naught at standard state, then F tends to P. This is the thing. Now second thing is this. Now I think I made clear everything, clear that what is ideal gas pressure and what is fugacity. Fugacity is addition of non-ideal thing into ideality is a fugacity. So now for a given gas, if a given gas is at a real condition, then how much it deviates from its ideality, it's known as a fugacity coefficient. And how to estimate that fugacity coefficient, that I am going to derive here. till now I have derived only what is a fugacity F. Now I am going to derive what is F by P. That is fugacity coefficient, can be denoted as a gamma, or some books used a phi. So now for getting a fugacity coefficient, what I am saying that first of all my real gas, it has a temperature and pressure T comma P temperature pressure. It goes to the ideal gas which is at T comma P. As we know that for a real gas I can, instead of P I can use F. For ideal gas I have to use P only. Second thing, this is path 1. The same thing I can do, the real gas I can take at low pressure, that is 1 atmosphere standard pressure, 1 atmosphere atmosphere pressure, real gas, and ideal gas is also at same thing, because at this point real gas and ideal gas possesses the same pressure, and from here I can again take to ideal point, that is, so I can say that delta G1 is equal to delta G2 plus delta G3. So if I will see that, if I will move real gas from real gas to ideal gas directly, or from real gas to standard condition, that is T P naught, real gas and ideal gas behaves at in the same way at a standard condition, that is T and P naught, that is 1 atmosphere, and from there if I can take ideal gas from standard condition to a real condition at a given temperature pressure. So with the help of this diagram I can estimate the fugacity coefficient, that is gamma equal to F by P. My aim is to estimate this thing only. So now I can know that delta G1, I can write delta G1 as, with the help of this formula, I can write delta G1 equal to RT ln of F by P by F, sorry, P by F, because I am moving from real gas to ideal gas, that's why F by P. Now delta G2, since it's a real path, then delta G2 I can write as a V dP from F to P naught, or I can write here from P to P naught plus integration of from P naught to P. This for ideal gas, its V is RT by P into dP. Why I cannot not write this V as RT by P? Because this path is for real gas. So if I will solve this integral, then I can, delta G2 was this thing, and this term is delta G3. Now I can write this thing as delta G1 is RT ln of P by F, which is equal to integration of P to P naught V dP plus integration of P naught to P RT by P into dP. So I can write here integration of P naught to P, V plus V minus RT by V minus V plus RT by P into dP. Just I have changed the order of this limits of integration. Then I can write here ln of F by P equal to integration of P naught to P RT by P minus V 1 by RT, which will give me ln of F by P is equal to, I can write here integration of P naught to P 1 by P minus V by RT. which I can easily write as ln of f by p equal to integration of p naught to p, that is 1 minus pv by RT upon P, which I can easily write as ln of f by P equal to integration of P naught to P 1 minus Z upon P into dP. So this is the formula of Fugacity coefficient, where Z is equal to PV by RT, that is deviation from ideality. So with the help of this small description, we can say that how my real gas is deviated from ideal gas by estimating this F by P, which is known as a Fugacity coefficient phi, gamma, and Fugacity we can estimate with the help of virial equation of state. In virial equation of state, the higher order terms like B1, B2, B3, they shows the non-ideality behavior, and this non-ideality behavior, if we will correlate with replacing some constant like F, that F with P, this F denotes the Fugacity. So I hope I have cleared the difference between Fugacity and Fugacity coefficient. In simple word, we can say that Fugacity is a real gas pressure, and Fugacity coefficient is the way this real gas is deviated from ideality. Thanks.